At exactly 3 o'clock in the afternoon, a stream of electromagnetic radiation completes an 8-minute, 93 million mile journey across the vacuum of space, strikes the south-facing glass of your home, and enters your living room. It arrives as light. It instantly collides with your hardwood floors, the fabric of your couch, and the dermal layers of your skin. At the exact moment of impact, the radiation undergoes a violent transmutation into thermal energy. The glass that easily permitted the light to enter now functions as a molecular barricade, refusing to let the heat escape. Your living room is a greenhouse. You can verify this structural failure right now. Walk to a south-facing or west-facing window on a bright summer afternoon. Do not touch the glass. Hover the palm of your hand exactly 2 inches from the pane. You will feel it. A distinct wall of warmth pressing into your human tissue before physical contact is even made. That thermal energy arrived as illumination. It passed directly through the glass, struck your interior architecture, and converted into heat. Most individuals suffer under the illusion that transparent glass is a neutral architectural feature. It is not. It lets almost everything through, but it does not let the heat back out. The United States Department of Energy calculates that windows are responsible for 25 to 30% of residential heating and cooling energy use. 15% of your wall space is generating a third of your structural thermal damage. Everything that enters your home as sunlight leaves as a metric on your electrical bill. The industry's prevailing answer to this architectural hemorrhaging is extreme. Tear the window completely out of the wall and start over. A standard replacement window runs $700 to $1,000. You will spend $7,000 for a 10-window home. It requires 20 to 30 years to break even on the energy savings. There is a devastatingly simple solution sitting completely ignored in the wrong aisle of your hardware store for decades. Solar control film. It is a microscopically thin filter, engineered from ceramic or metallic nanoparticles, suspended on a layer of polyester thinner than a single sheet of paper. You apply it to the interior of the glass using nothing but soapy water. The physical mechanism is elegant. It selectively bounces the infrared spectrum of sunlight, the heat back out through the glass, while allowing the visible light spectrum to pass unimpeded. The window remains a window. Your view of the yard is perfectly preserved. This is not the opaque, dark tint associated with automotive glass. Modern ceramic films are nearly imperceptible. Your neighbors will not know it is there. If you assume this application only aids outdated single-pane glass, you are incorrect. Standard double-pane windows still allow 65 to 76% of solar energy to penetrate the home. Film permanently terminates this influx. You simply close the door on the invisible heat, turning every sun-facing room into a sauna. Building engineers measure this thermal transfer using a metric called the solar heat gain coefficient. Untreated clear glass operates at a coefficient of 0,70 to 0,86, meaning up to 86% of the sun's energy successfully breaches the interior. The application of nanoparticle film plummets that metric to 0,25 to 0,6. More than half the heat is stopped precisely at the glass. No structural demolition. No frame removal. No construction crew occupying your house for 3 days. There is a secondary biological consequence to untreated glass that the window sales industry conveniently omits. Nanoparticle film forcibly blocks 99% of ultraviolet radiation, encompassing both UVA and UVB wavelengths. The Skin Cancer Foundation awards its official seal of recommendation to these window films. The identical seal they apply to medical-grade sunscreen. Here is why that physiological barrier matters. Standard residential glass effectively halts UVB rays, the wavelength responsible for acute sunburn. However, it permits more than 50% of UVA rays to pass directly through the pane. UVA radiation penetrates deeply into the human epidermis. It accelerates premature cellular aging and serves as a direct driver of melanoma. The New England Journal of Medicine documented the profound asymmetry of a 69-year-old delivery truck driver. After 28 years of chronic UVA exposure penetrating through the driver's side window, the left side of his face was deeply aged, hyperpigmented, and structurally degraded. The right side of his face appeared decades younger. Same genetics. Same face. The sole variable was the directional angle of the glass. In the United States, melanoma and non-melanoma skin cancers present with statistically significant higher frequency on the left side of the human body. The driver's side. This pathology is not a coincidence. If you sit adjacent to a window at your home or your office for a few hours daily, you are absorbing a compounding dose of UVA radiation that mathematically adds up. The film entirely arrests 99% of it. It is not a topical cream requiring reapplication every 2 hours. It is a singular installation persisting for 15 to 20 years. Furthermore, ultraviolet radiation initiates roughly 40% of the chemical fading in your flooring and furniture. Visible light drives another 25%. Thermal heat causes the remaining 25%. The film neutralizes all three vectors: the hardwood warping near the sill, the couch bleaching in the afternoon sun, the art slowly degrading on the wall. That molecular destruction is occurring, at this very moment, every sunny day. You are continuously paying the replacement debt, yet you never connect the liability back to the glass. That is the biological and property reality. Now, let us examine the thermodynamic and energy numbers, because this is where the disparity between this microscopic film and the expensive structural alternative becomes difficult to believe. The energy consulting firm Consul executed a rigorous study for the International Window Film Association. They tested film performance across 4 distinct Florida climate zones: Miami, West Palm Beach, Tampa, and Jacksonville. The researchers utilized the precise Department of Energy approved software mandated by the state of Florida for building energy code compliance. The resultant data proved the film cuts cooling costs by up to 30%. But that is merely the baseline. Here is the profound mathematical truth. The solar film was 2 to 4 times more cost-effective at saving energy than upgrading ceiling insulation from R30 to R38. It was 8 to 15 times more cost-effective than reducing air infiltration in the home. It was 3 times more cost-effective than replacing the air conditioning unit. Every traditional energy retrofit methodology, insulation, mechanical sealing, and heavy equipment upgrades, was mathematically defeated by a microscopically thin sheet of plastic pressed against the glass. This is not an insulated laboratory estimate. That is measured cost-effectiveness utilizing the exact software your state relies upon to verify building code compliance. The General Services Administration's Green Proving Ground program rigorously evaluated solar control film at the Goodfellow Federal Center in St. Second Louis. The Lawrence Berkeley National Laboratory conducted the independent analysis. Reflective films engineered to filter specific electromagnetic wavelengths reduced heating, ventilation, and air conditioning energy consumption by up to 29% in warm climates. This data is published transparently on a government server. The Department of Energy officially classifies window film as one of the most cost-effective building retrofits available, bearing payback periods as abbreviated as 3 years. That specific duration should halt you. 3 years. A complete window replacement requires 2 to 3 decades to balance the ledger. The microscopic film achieves it in 36 months. The arithmetic separating your options is definitive. If you apply the material yourself, solar control film costs $1 to $5 per square foot. A standard 15 square foot window requires $5 to $30. A 10-window residence costs $50 to $300. Professional installation adds a marginal labor fee, yet remains a statistical fraction of the alternative. The national average to forcefully tear out and replace a window is $650 to $1,000. That 10-window residence now demands $7,000 to $15,000. The Department of Energy calculates that low emissivity replacement windows reduce energy loss by 30 to 50%. The film delivers 20 to 30% cooling savings. You extract 70% of the performance for approximately 5% of the cost. Furthermore, there is a mechanical consequence homeowners routinely ignore. When your interior cooling load drops by 30%, your air conditioning compressor cycles for significantly shorter durations. The physical machinery works less aggressively. It survives longer. When mechanical failure finally necessitates a replacement, that lowered thermal load allows you to purchase a smaller unit. That translates to an immediate $500 to $1,000 reduction at the point of sale, compounded by permanently reduced electrical demand. Contractors mathematically size cooling systems based on your home's peak cooling load. The film decapitates that peak load. High-quality film lasts 15 to 20 years. Some installations hold fast for 25. It is a permanent upgrade to the glass that the construction industry ignores because it does not arrive enclosed in a prefabricated frame. Scientific objectivity requires addressing the seasonal inversion. What happens in winter? A standard solar control film blocks thermal radiation year-round. In July, this is the objective. In January, it simultaneously blocks the passive thermal gain you receive from a low-angle sun striking a south-facing pane. The Department of Energy dictates a straightforward rule. Solar control films perform optimally in climates dominated by long cooling seasons. If you reside in Phoenix, Houston, or Miami, the mandate is absolute. Film every window. If you inhabit a northern climate like Chicago, Minneapolis, or Boston, you have two distinct options. First, exclusively film your west-facing and east-facing windows. These exposures suffer brutal radiation in summer, yet contribute statistically negligible thermal gain in winter due to the Earth's shifting axial tilt. Your south-facing windows are your passive solar collectors. Leave them bare. Second, employ a low emissivity film. Utilize a microscopically thin metallic coating designed to reflect radiant heat back toward whichever side is warmer. During a freezing winter night, they act as a thermal mirror, bouncing your internal heat back into the room. In summer, they reverse the utility, reflecting solar heat away. These films reduce winter thermal loss by 30 to 50%. The 3M Corporation engineers a variant that elevates single-pane glass to near double-pane thermal resistance and pushes double-pane into triple-pane performance. A year-round film for year-round climates. In January, the glass is physically warmer to the human touch. The cold atmospheric zone near the window is eradicated. Your furnace idles. This is not a monolithic product. It is a highly engineered category. The precise film depends entirely on your geographic location and directional bearing. That nuance is exactly why a rapid internet query fails to yield a comprehensive solution. You must understand the physical limitations. A micro-thin polyester sheet cannot rectify a shattered seal or a rotting wooden frame. If your double-pane window is present with internal fogging, the structural seal has failed. That is a structural breach the film cannot touch. If the frame leaks exterior air, the frame is the issue. Film operates exclusively on structurally sound glass that simply transmits an excessive volume of radiation. Additionally, applying an incompatible film to double-pane windows with pre-existing factory tints can cause the glass to fracture from thermal stress. Consult the manufacturer's structural compatibility matrix. This is not a reason to abandon the upgrade. It is a mandate to spend exactly 5 minutes reading a label. If you find the result unsatisfactory, the film is cleanly stripped away utilizing a standard heat gun and a razor blade. It is not irreversible. If you lease your residence, you harvest the savings and peel the application off upon vacating. Some homeowner associations restrict visible exterior tinting. Fortunately, most modern ceramic films are nearly invisible to the human eye. Your neighbors will not notice. The physical application requires minimal mechanical skill. You cut a sheet of film 1 inch larger than the glass on all sides. You mist the pane with a solution of water and common dish soap. You peel away the backing, lay the wet film against the glass, and utilize a squeegee to forcefully push the moisture outward. The fluid and trapped air slide to the edges. You slice away the excess with a utility knife. 20 minutes of labor per window. The film requires several days to cure. It may appear hazy as residual moisture evaporates. Then, it clears entirely. On the next aggressively sunny afternoon, walk back to that exact same window. Hover the palm of your hand exactly 2 inches from the glass. The radiating wall of heat that pressed into your tissue yesterday is absent. The visible light remains untouched. The external view is unchanged. The glare on your monitor is halved. You are staring through the same silicon pane, but the invisible furnace that flooded your home with debt all summer has been permanently deactivated. Your mechanical air conditioning unit does not know why the internal environment changed. It simply stops fighting a losing battle. That is the precise moment the reality solidifies. Not an abstract percentage. The sudden absence of the ambient warm zone you tolerated every summer and never realized had a name. Nobody deliberately buried this. The material sits at your local hardware store. but a structural window replacement commands $700 to $1,000 per opening. An entire house project is $7,000 to $15,000. The contractor who informs you about a $5 sheet of plastic just eliminated the reason you called them. The installer recommending film does not secure the $1,000 contract. More subtly, the bureaucratic architecture of our energy sector is misaligned. Building codes, government programs, and tax credits are rigorously structured around the window as a manufactured unit. U factor and solar heat gain ratings are explicitly stamped onto the physical frame. Film is a post-market retrofit. It radically alters the physics of the existing glass, but it does not change the printed label. There is no Energy Star certification for an old window augmented with new film. The system measures products, not solutions. The solution that costs a mere fraction and delivers the vast majority of the performance simply does not fit the bureaucratic spreadsheet. The economic incentives are not actively aligned against you. They are simply not aligned toward you. Your windows are the weakest structural surface in your home. They constitute 15% of your wall space, yet they are responsible for a full third of your energy expenditure. The most economically efficient correction is not new glass. It is a microscopic film that costs $5 per window, installs in 20 minutes, persists for 20 years, halts 80% of the heat, neutralizes 99% of ultraviolet radiation, eliminates glare, preserves your interior assets, and actively extends the operational lifespan of your mechanical systems. And it has been sitting ignored in the wrong aisle with no signage explaining what it actually accomplishes. Tomorrow afternoon, locate your most heavily irradiated window, position a digital thermometer exactly 2 inches from the interior pane, and physically measure the baseline of your own thermal debt. We possess the molecular engineering to halt a 93 million mile stream of cosmic radiation, yet we choose to let it quietly burn us because the solution was too cheap to be noticed.